Welcome to today's practical for WAEC 2024 on electricity. We have all the things set up. We are going to take this experiment step by step, starting from the procedure, and then at the end, we'll get our readings and plot our graph. Please do well to watch this video to the end and drop your comments. It's open to correction and very open. Drop your comments. If there is anything you think I can do better or predict the practical better, you can let me know. Drop it in the comment section, and also try yours with your students so that we'll all get a better result. We have one aim, that's our students passing very well. So we just have to put heads together, predict things like this, check past questions, try out experiment like this, get readings, plot our graphs, and then come to a final conclusion to prepare our students before the exam so that they won't be novice in the exam hall. That is why we are doing all this. Okay, so let's go right into the video. We were asked to provide two resistant wire of different materials. So I have this one, the Constantine wire, and I have another wire, copper wire. These two ones, I opened them. So this one is the first wire, then this is the second copper wire. So that's what we are going to use. We were also asked to provide a meter bridge. This is a meter bridge. Then 1 ohm resistor. This is the 1 ohm resistor. We were asked to provide a cell. Just one, please, a cell. Then this is the jockey. I'm going to show you the connection. Then we were asked to provide the rheostat. This is the rheostat. Then these are the wires and a galvanometer. So let's look at this circuit diagram and follow the procedure to do our connections. This is the procedure we are going to take. You are provided with two wires marked P and Q, a resistor Rx, 1 ohm, and other necessary apparatus. Connect Rs in the left-hand gap of the meter bridge. Okay, that's the first thing. We are to connect Rx. This is Rx connected to the left-hand side of the meter bridge. Okay. We are following the procedures, and this is how you should read and follow WAEC instruction. Read and follow the instruction that will be given on that day. Connect RS in the left-hand gap of the meter bridge. A length L equal 100 cm of wire P in the right-hand gap of the other apparatus as shown in the diagram above. This is the other end of the meter bridge where we'll be connecting the wire. You can see it here. We'll be connecting the wire, then here we'll be connecting the 1 ohm resistor. Look at the circuit diagram we are going to use to connect. From the circuit diagram, we have R, then we have the wire L, then the galvanometer. It will be connected to the cell, the positive end of the cell. This is the positive end of the cell, so it should be like this. Then the negative is connected to switch. This is the switch, and then to the rheostat. So let's do the connection. You can see the circuit diagram. Just screenshot it. That's the circuit diagram we are going to use for the practice today. So this is the 1 ohm resistor. Then see how I connected the galvanometer to the meter bridge. This jockey is connected to this end, and then this positive part, I connected it to the meter bridge. This one is the switch. This is the key to ensure tight connection. and ensure tight connection. So one, I'll switch. Then this is the rheostat. So following the diagram, key or switch to rheostat, then back to the meter bridge. Then this is the length of the wire we are going to be measuring out 100 cm. We'll be measuring out 100 cm, okay, for the first wire. Then this is the meter bridge, everything in place. I will just hold it, slide my jockey and take my readings. But let me first measure out 100 cm. So for the first 100 cm, I will start with this Constantine wire. Let me start with it. I'll place this here. And ensure that it's tight, ensure tight connection. See how I connected the rheostat. Then this one, okay. So I will measure out 100. I'll measure out 100 cm. That's for the first length as we were instructed from the procedure. I'll measure out 100. So once I get the 100, I will do this is the 100. I'll put it here. Ensure tight connection, ensure tight connection, and then cut out the parts that I don't need. I will cut out the parts that I don't need out of this first wire. Good. So let me go back to the procedure. Now that I'm done with the connection, please ensure tight connection. That's why I'm always checking to see if there is any gap, because if any of the part is not tight, it will affect our readings. We will not get any readings. Okay. So the next thing, let's go to the procedure and know now that we have followed the circuit diagram to do the connection. Determine the balance point B on the meter bridge AC. Measure and record AB, which is equal to LX, and BC, which is equal to LP. Then evaluate R1 is equal to LP over LX all over in brackets, then RS. Repeat the procedure for 4 other values of L: 90, 80, 70, and 60 cm. In each case, obtain and record the values of LS and LP and evaluate R1. So we are going to do that. Then repeat the experiment with the second wire Q. Obtain values of LS and LP for each length of wire as used in the wire P. Evaluate R2. So we are going to do for the first one, which is following the circuit diagram, we'll get the balance point. We are going to do it for the first one. After doing it for the first wire, we'll do for length. Remember, we have to do for 90, 80, 70, 60. After that, we'll do for the second wire. Okay, let's follow the procedure and get our table of values. This is how the table of values will look like. I did it for the first wire. We'll get LX, get LP. Then we were asked to evaluate R1 will be LP over LX, then RS. Remember, these are RXs, 1, remember. Okay, then we'll do for the second wire LX LP, then get our R2. So we are going to do it for 100 cm, 90 cm, 80 cm, 70 cm and 60 cm. This is how the table of values will look like. Please remember to put the units cm, 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 then R1 will be in ohms because this cm will cancel this cm. So it's this R that will be left. The same way we do for the second wire. That's how we. So let's go right into the practical. Please subscribe to this channel. Just hit the subscribe button. It's for free. Hit the subscribe button, like this video, and I know you're enjoying it. Okay, let's continue. Closing up this part and measure out 90 cm for the second wire. So let me measure out 90. Let me measure out 90. Remember, there is room for error. There is room for correction. But this is my prediction, and I'm open for your own suggestion to make it better. I will show you the procedure I followed. You know, I read it at the beginning, so I will also show it. Please hit the subscribe button, like the video. Thank you. So this is for 90. I will just cut off this part that I don't need. I like cutting it out. So now that I've cut it, I will do for the same procedure. Okay, let me do fast. For this, I will make sure hold this. You can use sellotape if you want, but I want to, since it's only one cell, let me be holding it so that I will ensure that it's fixed and tight. So if you have other better thing, you can use it. Now that I'm holding it, okay, I'll close the key, close it, and then pick my jockey and start checking. See where the galvanometer is deflecting. So we are looking for, this is 50. Okay, 52. 52 is 10 minutes for 90. You see how it's going? Okay, until I get the 0 point. And that's at 22. Let's try 25. Is moving away. 24 is not good. 23. 22 is giving a very good one. So we'll use 22. 22 cm. I'll open up this. I'll do for length 80. I'll change this and measure out 80 cm. Cut out the parts that I don't need. This is 80 cm. Okay, this is 80 cm. Okay, if you like, you can leave your own, but I like cutting out the parts that I don't need. 80 cm. Then I'll go ahead and take my readings. Close the key and then take my readings. You see it's still far. You see where it's going, so I need to move my hand this way. I'm at 40 now. You see the way it's going? You see the way it's going? 34. Okay. I'm trying to slide the jockey gently. Okay. At 21, is moving to the other side. 22, 22.5, 23. Okay, let's go with that since it's zero now. Okay, I've recorded 23.00. So for 70 now, okay, this is for 70. I'll put it. You see where 28 is, 27 is still slightly 25. 25 is okay. 24 is moving away. You see, 24 is moving away, so 25 is okay. I'll record it 25.00. For the last one, which is 60, let's do for 60. This is 60. For 60 now, let's check what we are going to have. I'll close the key and check. You see where it's going? It's still moving. Okay. You see 27 is slightly moving to the other side. 26 is moving to the other side. So I'll come back to 28 and check. Okay, we'll take 28. In order not to make the video too long, I'm going to replace this. I'll replace this with this wire and repeat the same procedure for 100, 90, 80, 70 and 60 for the copper wire, and record it on the table of values so that we can plot our values and see what we get. Okay, it's time for us to complete our table of values and plot our graphs. Please feel free to drop your comments, like this video, subscribe to this channel. Please drop your comments. Your values may be different from my own. It must not be the same. It depends on the wire you are using. So try it out yourself. If there is any improvement, let me know. Since there is still time, I can still do more. So feel free to drop your comments. Thank you. Okay, let's complete the table of values. Remember that we want to find from the circuit diagram we have Lx and Lp. So that Lp will be 100 minus Lx. So let's start. The first one, 100 minus 20, that's 80.00. Then the second one, 100 minus 22, that's 78.00. Then the third one, 100 minus 23, that will give us 77. Your values may differ. Just that when I pick my values, I try to pick values that will make it very easy for me in plotting. 75.00. Then the last one, 100 minus 28, that's 72.00. Okay, let me finish that off. For the second wire, I will repeat the same thing. 100 minus 52, 48.00. 100 minus 53, 47.00. 100 minus 54, that's 46.00. 100 minus 54.50, 45.50. 100 minus 55, that's the last one. Your values may differ, remember. So this one I have 45.00. Okay, the most important thing is look at the length. You can look at this one is decreasing. Increasing. Decreasing. Increasing. Decreasing. So let me use this formula, LP over LS times RS. Remember that our RS is 1. So let me complete the table so that we'll continue. This is what we have, and I'm going to plot what we have. Please, whatever your reading is, plot it. There is one thing about physics. Remember that the relationship between R and the length, R, the resistance, is directly proportional to the length, which means as the length is decreasing, the resistance is decreasing. Now look at our value. What matters is how consistent your value is. Now R4 3.5 is decreasing. The length is also decreasing for the first wire. For the second wire, as the length is decreasing, you see the resistance is also decreasing, which is in line with the theory. As the length is decreasing, the resistance is decreasing because they are directly proportional. So once what you have is in line with the theory, feel free to plot your graph. The only thing is that the first wire is made of Constantine wire, the second wire is copper wire. So copper has less resistance. You can see the range 0.8, 0.8. This one has more resistance, that's more resistivity, the Constantine wire, more than the copper wire. That's why you are seeing the variation in the values. But if it's for as the length is decreasing, the resistance is decreasing. We are expected to tabulate your readings, plot a graph of R2 on the vertical axis, against R1 on the horizontal axis. Determine the slope of the graph, then evaluate K is equal to root X. So let's plot our values. Okay, R2 against R1. Let's see the nature of the graph. Please do well if you have not watched my videos on how to plot graph, how to plot close values, you can watch it. And also the video on the question 1, that's relative density of liquid. Please watch this video. Okay, so this is R2. R2, please put your unit in ohms. R1, put the unit, then 0, so that you can get your full marks. Please put the unit. Then let's label it graph of R2 against R1. Let's choose our scale. Let's choose our scale. For R2, which is the vertical axis, see the values that we have. To get a larger graph, we can use 2 cm to 0.1 units. Okay, we'll say R2 axis, write your scale. R2 axis, 2 cm is equal to 0.1 units. Let's use that so that we can get a bigger graph. This is 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. So this one is 1.0. For the R1 axis, we need 1, 2, 3, 4, 5. So for us to get a bigger graph, let's use 2 cm to 0.5 units. So we'll say R1 axis, please write your scale. 2 cm is 0.5, so that we can have here to be 0.5, 1.0, 1.5, 2.0, 2.5, 3.0, 3.5, 4.0. So the highest value entered, that's the most important thing. 4 entered, and this one, the highest value 0.9 entered. So we'll have the graph here. Now let's start. When R1 is 4, 0.92. Okay, for this one now, when is 4 here, this is 4, we'll look for 0.92. How do we locate 0.92? Remember, from here to here is 0.1, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines inside. So this 0.1 units divide by the 10 lines inside, that will give us 0.01. So which means this is 0.1, 0.11, 0.12, 0.13, 0.14, 0.15, 0.16, 0.17, 0. Just like that, 1819 until the next one. So if you want to get it, just check the range, divide it by the number of buses, and always use factors so that it will be easy for you to count. So when it's 4, we have 0.92. Here is 4. This is 0.9. From here, remember, this is 0.91, 0.92. So I will come here, keep this at the second small line inside, and merge it with where 4 is. That's this one. So the next one, when is 0.89, if we get 0.89 here, we'll get 3.55 from R1. Remember that here the interval is 0.5. So now 0.5 divided by 10 small lines inside, that will give us 0.05, which means that here is 3.0, 3.05, 3.1, just like that, 3.15, 3.2, 3.25, 3.3, 3.35, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9, 3.10, 3.11, 3.12, 3.13, 3.14, 3.15, 3.16, 3.17, 3.18, 3.19, 3.20, 3.21, 3.22, 3.23, 3.24, 3.25, 3.26, 3.27, 3.28, 3.29, 3.30, 3.31, 3.32, 3.33, 3.34, 3.35, 3.36, 3.37, 3.38, 3.39, 3.40, 3.41, 3.42, 3.43, 3.44, 3.45, 3.46, 3.47, 3.48, 3.49, 3.50, 3.51, 3.52, 3.53, 3.54, 3.55, 3.56, 3.57, 3.58, 3.59, 3.60, 3.61, 3.62, 3.63, 3.64, 3.65, 3.66, 3.67, 3.68, 3.69, 3.70, 3.71, 3.72, 3.73, 3.74, 3.75, 3.76, 3.77, 3.45, then 3.5. You see how to get all these small values. So here is 3.5, and what do we need? We need 3.55. That's this one. After 3.5, 3.55 is the next one. Okay, then we'll go and look for 0.89. This is 0.8, 81, 82, 83, 84, 85, 86, 87, 89. So we'll do for the other one. When it's 0.85, we have 3.35. 3.35, this is 3, 3.5, 3, 3.05, 3.1, 3.15, 3.2, 3.3. So we have it to be here. We'll trace it down and then look for 0.85. This is 0.7, this is 0.8, 81, 82, 83, 84, 85. Somewhere here we'll put it. You know that the values are going to be close because we started with 0.1, but we are having it at 0.8, so it's almost going to be up. Then the next one is 0.83, somewhere here. This one is 3. We'll look for 3 and look for 0.83, 81, 82, 83, and mark it. Then we'll look for the last one when it's 0.82, this is 2.6, this is 2.5, and 0.82. 81, 82, this is 2.5. We are looking for 2.5 and 2.60. 2.5, so 2.60 is this one, and 0.82, 81, 82, somewhere here. Okay, this is how what we'll have. The next thing we are going to do is to look for the best 3 that entered. This is the best 3 that entered. These other ones, they are below across the best line of it, so I'm picking this. Then let's get our slope. You can see it has intercept at 0.5. So let's take our slope. Please, the bigger the triangle, the more accurate for the slope. I'm picking this and I'm picking this side to get the slope. Please don't forget to subscribe to this channel and like this video. Let's find the slope and evaluate k to be equal to root of the square. So we are picking the slope. We plotted R2 against R1. So the slope is going to be change in R2 over change in R1. The slope will not have any units. R2 and R1 are in ohms, so they will cover. Please don't use X and Y, is maths, is physics, not mathematics. So at this point, I'll pick 0.9. Okay, it's in between, let's say 95. 0.95 minus, I'll come back here, this is 0.5 over, then trace it down to this point, 4.0 minus, on this point that I picked 0. Okay, so let's get the slope. So I will have 0.45 over 4, which will give me 0.1125. Okay, so this is what I have. Your own may not be the same. It depends on the wire you are using. So let's go to the precautions. I ensured tight connection of the wires. I ensured that the key was opened when readings are not taken. I ensured that the jockey was tapped gently on the bridge. I ensured that I avoided zero error on the galvanometer. I ensure that I avoided error due to parallax when reading the length from the bridge. So you can learn the two. You'll be expected to give two precautions and then answer questions below. Thank you for watching this video. I hope you got value. Please like this video, share it, drop your comments. It's open to more practicals. I'm open to more. Since the exam is still far, I'm open to do more based on the comments I'm getting. Thank you so much for watching to this point.